Good day, students. You're welcome to this class where we'll be dealing with the identification of angles. We're going to be identifying angles, and we're going to be looking at their properties and see how we can, answer questions that are based on these angles. If you remember, we have had a session of interaction on this, but we need more explanations on this topic, and that's why this video is coming up. So I would like you to listen attentively and follow intensively. Now, our learning objective is that at the end of this class, you should be able to identify, to name, and to calculate angles on a straight line. And also that you should be able to identify, to name, and to calculate angles meeting at a point. And last but not the least, you're going to also be able to identify, to name, and calculate angles involving a transversal and parallel lines. Alright, so these are the three things that you must be able to do at the end of this video. So I want you to watch out for those things and keep them in mind. The first thing we are going to deal with is angles between lines. And it's important for you to know that angles are formed when two or more lines meet. You see, every single time that two or more lines meet, an angle is formed. And the point of intersection between those two or more lines is called the vertex. Okay, I'm sure you remember that from our plane shapes. Okay, the vertex is the point where those two lines meet, and it is at that point that an angle is formed. Every single time that two lines meet, an angle is formed. So for example, if you had an horizontal line like this, if you have an horizontal line like this, and then you have a vertical line like that, the point of intersection will have angles formed. There'll be angles formed at that point of intersection. This is an angle. It's angle 90 degrees because it's the angle between the vertical and the horizontal, a vertical line and an horizontal line. So that's angle 90 degrees. So you can see that the angle is formed on the right side and on the left side as well. Okay, angles are formed when two lines meet. I'm sure that you remember this. We already did this in our interaction. If you had this line rather than the other one, if you had this line like this, it's still the same thing. An angle is formed, or two angles as a matter of fact are formed because two lines are meeting each other. So you have an angle at this side, which is the right side, and then you have an angle at the left side as well. So you could have a line like this. You could see that there are two lines and then they meet, but both lines are horizontal, so it continues as though it has formed a single line. We are still going to deal with this more as we go on in this class, but that is not to say that an angle is not formed. An angle is still formed even though these two lines are meeting. They are both horizontal lines and they form like a single line that is continuous. All right, an angle is still formed between them. Okay, so keep that in mind. Every single time two lines meet, two or more lines meet, an angle is formed. The next thing that is also very important for you to know is that a protractor is what you can use. Most of the time, that's what is accessible to be used to measure an angle. So when two lines meet, how do you know the angle that they form? Okay, you need a protractor, and what the protractor does is that you can use it to measure your angle. And this is a sample of a protractor right there on your screen. You can see that there are two scales on the protractor. Right here you have what we call the outer scale, and it's graduated from your left hand side to the right hand side. You can see your 0 on the left hand side. Okay, that's the outer scale. 0 is on the left hand side, and then you go 0, 10, 20, and then you go around until you get to 180 on the right hand side. So the outer scale runs from 0 to 180, which is from left to right. Okay, that's clockwisely. Okay, follows the hand of the clock. Whereas the inner scale, your 0 is on the right hand side. So if you can use any of these two scales in measurements. Some of you are already aware of that. Some of you had a challenge with this. Okay, you can use any of these two scales for measuring an angle, but you must be sure that you're starting from 0. So if you want to use the outer scale, you make sure that you're starting from 0 and you're counting towards your right hand side. And if you're using the inner scale, you must make sure you're starting from the right, which is 0, and then you're counting towards your left hand side. Okay, so this is what that looks like. You can see that in your mathematical set. All right, now if you want to measure an angle using a protractor, what you need to do is to place the middle point of your protractor on the vertex of the angle. The middle point, you already know that's point in the middle right there. Yeah, that point right there in the middle. Okay, and the vertex is the point where those two or more lines meet. So when you put the midpoint at the vertex, then the next thing you do is to line up one side of the angle with the 0 line of the protractor. So what you'll do is that, remember we said that two lines, when they meet, they form an angle. So one of those two lines, you choose whichever one you prefer, you would ensure that after you have placed the midpoint of a protractor at the vertex, you ensure that one of those two lines is on 0. It could be in the inner or in the outer scale, doesn't matter. Okay, but it has to be on 0, whether in the inner or in the outer scale. And then lastly, you read the degrees where the other side crosses the number scale. Okay, so there are two lines, remember, minimum, that forms an angle. So you place one of those two lines, you place it on 0 on your protractor, okay, and then you read the degrees of the other line. So you place one line on 0, and then the other line you read where it crosses the number scale. Okay, and you can do this either for the inner or the outer scale. Now it says here that you should take care to read from the right set of numbers. A protractor has two sets of numbers. One set is from 0 to 100, the other is from so the first set is from 0 to 180, and the other is from 180 to 0. The one you read depends on how you place the protractor, so it depends on you. So place it so that one side of the angle, it lines up with 0, and then you read that particular scale. Okay, so if one side of the angle aligns with 0 in the inner scale, then you are reading the inner scale, and if one side is aligned to 0 on the outer scale, you are reading the outer scale. Okay, so now as an example, if you want to measure the angle that is formed in these two lines are meeting right here, and an angle is formed. If you want to measure the angle formed, you need to place your protractor like this. You can see that the midpoint is on the vertex, just like this, and you can see that one of the two lines that form the angle is on 0. You can see that this line right here, this horizontal line, is on 0 and on 180. But we said you are going to read the scale where it is on 0. You will not start reading from 180. It means that we cannot read the outer scale in this example. We have to read the inner scale, because one of the two lines that form the angle is on 0 in the inner scale. So we are reading from the right hand towards the left, or in the anti-clockwise direction. So this side lines up with 0 degrees in the inner scale. So the inner scale is used to measure the angle. And then of course this other side, if you use the inner scale, you have 0, you have 10, 20, 30, 40 is right here. And if you count the little the little markings, 1, 2, 3, 4, 5, you realize that the second line is on 45 degrees. And what that implies is that the angle formed between the two lines is angle 45 degrees. Okay, it is as easy as that. We did all of these in class already, so I'm sure that you already are familiar with this. Now, if you want to measure the angle between these two lines, you do exactly the same thing, but this time around you're going to have to turn your protractor over so that the vertex and the midpoint of the protractor will be at the same place, and then one of the two lines will be aligned with 0. One of the two lines will be on 0, and you can see this line, this horizontal line, is on 0 in the outer scale. So this time around we're not going to be reading the inner scale, we'll read the outer one. Okay, so you have this side lines up with 0 degrees in the outer scale, so the outer scale is used to measure the angle. And then if you look at the other line here, you can see that it intersects the protractor at 140 degrees. If you read the outer scale, you can see 0, 10, 20, 30, up and up like that until you get to 140 degrees. So it means that the angle between those two lines is 140 degrees. So this is quite easy. You can actually do it. You can draw any two lines as long as they meet at a particular point. You can always know the angle that is formed between those two lines. So as an example, if you wanted to answer this question, some of you already answered this in class, but let's see it once again. If you wanted to answer this question, the angle formed between these two lines, you can see that the horizontal line is on 0 in the inner scale. It means that we'll be reading the inner scale and not the outer scale. So we start from 0, 10, 20, 30, 40, 50, 60, 70, and then we count 1, 2. Okay, so the angle formed here is angle 72 degrees. It's as easy as that. Okay, this is another example. As you can see, of course the vertex is aligned to the midpoint of your protractor, and then one of the lines is on 0 in the outer scale. You can see that right here on the left hand side. On the outer scale you have 0, so you read the outer scale. So you have 0, 10, 20, 30, 40, and the second line is on 50 degrees. So you have your answer to be 50 degrees. That's the angle between those two lines. And then we have this as well. In this case, can you first and foremost guess what I don't even expect you to guess. I expect you to already know what to do. Okay, can you see if you can get it? What scale are you going to use, and then what will be the answer if you used that scale? Alright, you will use the inner scale, and that's because one of the lines that form the angle is on 0 in the inner scale. Okay, so you're going to read the inner scale, and then you go 0, 10, 20, 30, on and on until you get to 120. You can see 120 right here, and then after getting to 120 you need to count the smaller lines. 1, 2, 3, 4, 5, 6, 7, and that gives us 127 degrees. Now I remember that in class, when I asked you this question, a few of you answered 133 degrees, and I told you that you were wrong because you are reading from the right towards the left. So you get to 120, you are counting towards 130. So it is not from 130 upwards. Okay, it is not 133 degrees, it is 127 degrees, because you are counting from 120 towards 130. Okay, I hope you understand that very clearly. And then we moved to angles on a straight line, and we said that it is possible to have a straight line like this. You have a line, and then another line comes and joins it like that, and this time around they both just form a straight line, and we can't tell which angle is which or which line is which, but we know that two lines came together to form this straight line. What is the angle that is formed on this straight line? And we said, okay, let's use our protractor to give us an answer. So we put our protractor like that. You remember there are two lines. There is one to the left and the other to the right. And if you look at it, if we start reading from our left using the outer scale, you'll see that one of the lines is on 0. So we can read the outer scale and follow it until we get to the second line, which is on the right hand side. And then you go 0, 10, 20, 30, on and on until you get to 180 degrees. It means that the angle between these two lines, the one on the left side and the one on the right side, is 180 degrees. Of course, if you use the inner scale as well, you will get 180 degrees. Only difference is that for the inner scale, you will start from your right hand side and then read towards your left hand side. Okay, so it means that the angle formed here, theta, is equal to 180 degrees. Now, it's possible for us to divide those two lines into two to make it obvious. So we decided to bring this vertical line and put it between them. Now, if this is the case, then we can read from our left hand side using the outer scale. Remember, one of the lines is on 0. That's the outer scale. So we read up till the line that is on 90 degrees. So on the left hand side, you have 90 degrees. Also from the right hand side, it means we are reading the inner scale on the right hand side. So we read from 0 to 90 degrees. And then adding those two together, you still get 180 degrees. Okay, and it's possible for us to divide the line this way. In this case, you know that there are three lines now. There are two horizontal lines that have joined together to basically form a single line, and then there is a third slanting line that is on top of them. Okay, and if I start reading from my left hand side using the outer scale, I'll start from 0 and read to 40. You can see that other line is on 40 degrees, so I have 40 to the left. And then if I want to read from the right, I have to read the inner scale, so I'll start from 0 and then I go inner scale, I go, and then I have 140. So I have 40 on one side and 140 on the other side, which still gives me 180 degrees. And what this implies is that the angles on a straight line add up to 180 degrees. It doesn't matter how many times you divide it, as long as they are angles on a straight line, if you add all of them together, your answer will be 180 degrees. And if you remember, I told you to write this down because it is so important. Okay, the angles on a straight line add up to 180 degrees, or sometimes you could say what's the sum of angles on a straight line, and of course the answer is 180 degrees. Okay, so did a few examples and I'm going to run through them because we already did all of these in class. It's just like a recap. We haven't gotten to the part where we have not been able to trash well in class. So if you have these example, there is an angle on a straight line here which has been divided into two. You can see one part is A and the other part is 50. So we can answer this by saying that the sum of angles on this straight line is 180 degrees. That is, if I had A and 50 together, I should get 180 degrees. And then of course I subtract 50 from both sides and my A would be 130 degrees. The second question, basically the same thing. A straight line, sum of angles is 180 degrees and the angle has been divided into B and 137 degrees. So if I had B and 137 degrees together, it will give me 180 degrees, and then I'll subtract that. B would be equal to 180 degrees minus 137 degrees, which would give me 43 degrees. Okay, and then the last but not the least, you have this particular one. This angle on a straight line has been divided not into two now but into three. The first part is C, the second part is 90 degrees, and the third part is 67 degrees. But that doesn't change anything. The sum of angles on a straight line is still 180 degrees, and then if you add those three together you get 180 degrees. Of course 90 and 67 will give us 157 degrees. So if you subtract 157 degrees from both sides, then you get 23 degrees as your final answer. Okay, so basically that's what to do in those cases. And then in class as well, we treated this first exercise where most of you got them right. Okay, but for those of you who didn't get them right, or you were not in the class, I wanted to just try these questions, and if you have any problem with them, of course you know how to reach me through my email. Just send me an email and ask whatever questions you have about this. Of course, question 1, the angle on a straight line has been divided into two parts, so you know what to do. In question 2, it's been divided into 3 parts, and in question 3, it's been divided into 4 parts. So basically the same thing that we've been treating. So we'll move from there to vertically opposite angles. And vertically opposite angles, let's see how we can spot that. If you have a line like this, you have this bent line, and then you have another line that crosses it like that. There are angles formed on this straight line. Remember that the sum of angles on a straight line is 180 degrees, and this other straight line has come to divide that line into two. But these two parts are not equal. So I want to measure the angle formed here and the angle formed here. I want to know how this line divided the straight line into two. So I place my protractor like that. Okay, I'll start from my left hand side. I'll use the outer scale. You can see it right there. I start from 0. I go outer scale. I land on 100. It means that to the left here I have 100 degrees, and then I come to the right. I also start from 0, and then I follow the inner scale, and then I have 80 degrees. So it means that on this side I have 100 degrees, and on this side I have 80 degrees, which makes total sense, because if I had 180 together, it gives me 180 degrees, which is the sum of angles on a straight line. I'm sure you remember that already. Okay, but there is another angle formed at the lower part of this straight line. I want to also know what angle is formed here and here. Okay, so I will turn my protractor over and try to measure the angles at the other side of that line. I'll start my outer scale from the right hand side this time, because my protractor is upside down. So I'll read from 0, and then I follow the outer scale until I get to the second line right here, which is 100 degrees. And then I go to the inner scale. I start from my left hand side. I start from 0, and then I come up until I get to 80 degrees. So it also implies that right here on the right I have 100 degrees, and on the left I have 80 degrees. And this brings up something interesting. You can see that the two angles that are opposite each other are equal. These are this is what we call vertically opposite angles. Okay, when two straight lines cross each other in such a way that they make an X, so these vertically opposite angles sometimes could be called the X angle as well. When two straight lines cross over each other to make an X, each pair of vertically opposite angles are equal. You have to write that down. Vertically opposite angles are equal. Every time that you see two lines forming a giant X, okay, the two angles that are opposite each other are equal. Okay, just like we have proven in this demonstration of here. Okay, so if we would let's look at an example on that. We have this example. We did this in class, I'm sure you remember. We want to find the values of x, y, and z, and of course x and 146 are vertically opposite angles. You can see that there's a giant X right here, so the angle x and 146 degrees are equal. So it means that since vertically opposite angles are equal, then x is equal to 146 degrees. And then we can also see that the sum of angles on a straight line is 180 degrees. Okay, and y along with 146 actually form a straight line. Okay, y and 146 form a straight line. So if you had y and 146 together, you should get 180 degrees. Of course, you subtract 146 from y, and your final answer will be 34 degrees. Okay, so your y is equal to 34 degrees. And obviously, if y is equal to 34 degrees, then z would also be equal to 34 degrees because it is vertically opposite to y as well. Okay, and so we have answered the question. We got the value of x, the value of y, and the value of z. Okay, so next we'll move to angles at a point, which we have also treated in class, if you remember. Angles at a point. If you have a point like that, you have a point, and you decide to draw a straight line through that point, just like this. Now you remember that an angle is formed at the upper part of the line and at the lower part of the line. If you use your protractor, which I don't think you need anymore because now you already know that the sum of angles on a straight line is 180 degrees, so it means that the angle formed here would be 180 degrees, and of course the angle formed at the lower part will also be 180 degrees. So if I asked you for the sum of angles around this point or at this point right here, then you simply add the two angles together to get 360 degrees. Okay, and what applies is that the angles at the point, or the sum of angles at the point, is 360 degrees, and the angles at the point add up to 360 degrees. And this is also very important. I told you that it is the third thing you're supposed to write down. The first one was that the sum of angles on a straight line is 180 degrees. The second one is that vertically opposite angles are equal. And the third one is this, that says that the angles at a point add up to 360 degrees. It's important to not forget that. Okay, and then I think this was where we stopped in class, where we wanted to deal with these exercises, and some of you had challenges with them. Now I will answer the first question for you. I'll just explain how you're supposed to get the answer for the first question, and then for those of you, I think for all of you, you should all attempt to answer the remaining 3 questions. and then you send me your answers as an email. All assignments that you are given should be submitted by Friday. Okay, so this will be your first assignment. This second exercise will be your first assignment, and you have to submit by Friday. Okay, this will not be the only assignment I'll give you anyway, so there'll be 2 of them, but I expect both to be submitted by Friday. All right, so how do you answer the first question? There is a point here where 3 lines meet. Remember, we said that when 2 or more lines meet, an angle is formed. Now we have 3 lines meeting at this point. Now if you see this circle right here, it's showing us that there is an angle around that point. And if I asked you what the sum of angles around a point is, obviously your answer is 360 degrees. It means that all the angles surrounding this vertex here should add up to 360 degrees. But these angles have been divided into 3 parts. The first part is 40 degrees, the second part is 80 degrees, and the third part is A. Now it means that if you add those 3 parts together, you should get 360 degrees, because that's the sum of angles at a point. So if I say A plus 40 degrees plus 80 degrees, it gives me all the angles, which is equal to 360 degrees. Okay, of course, if you had 80 and 40 degrees, you get 120 degrees, and then you subtract that from 360 degrees to give you 240 degrees as the value for A. Many of you got the answer right, just a few of you that didn't get it right, and I hope that in explaining like this, you're able to understand what we're saying. That point, this vertex here where the 3 lines meet, there is an angle surrounding it, there's an angle around it. It is that angle that we demarcated with that large circle, with that circle that surrounds that point. Okay, and if you had all the angles at that point, you'll get 360 degrees, and these angles have been divided into 3: 40, 80, and A. And now we have to find the value of A. So if I had 40 and 80 and A together, I will get 360 degrees, and I'm sure you know what to do from there. So you will answer questions 2, 3, and 4. Everybody, not just those that didn't get it in class. Everybody should answer questions 2, 3, and 4, and then send to me as an email. So make sure that your work is neat. I will expect you to draw each diagram and label them right, and then you solve the questions and you scan them, make sure they are clear and neat, and then you send to my email so that I can attend to them and give you a feedback. Okay, so you have to do that latest by Friday. Then we move on to angles formed between parallel lines and a transversal. Now we haven't done this in class, so I want everybody to make sure that they listen as attentively as possible. Angles formed between parallel lines and a transversal. Now, first thing that I'll inform you is that a transversal is a line that joins 2 parallel lines. Okay, anytime you see a line that joins 2 parallel lines, that line is called a transversal. But then what's a parallel line, or what are parallel lines? They are lines that can never meet, because the distance between them remains constant. So if you draw through 2 lines, okay, and you make sure that the distance between them does not reduce, then those 2 lines will never meet. No matter how long you draw them, they are not going to meet, because the distance between them is not reducing at any point in time. Okay, those are called parallel lines. Okay, so many times people say parallel lines are lines that can never meet, but the reason why they cannot meet is because the distance between them is unchanged. Okay, so if you have a line like this, you have a line A, an horizontal line, and then you have a line B. These are parallel lines, and the reason is because you can see that the distance between them is constant. If I continue to draw line A and B endlessly, okay, they are never going to meet, because the distance between them is not reducing. Okay, so these are parallel lines. And then if you have line C like that, okay, that is what you would call a transversal. It's a line that connects 2 parallel lines together. So we label that lines A and B are parallel lines, while line C is called a transversal. Okay, this is important to not forget. Okay, and so the first kind of angle that is formed between parallel lines and a transversal is what we call alternate angles, and sometimes it is called the Z angle. Now you have to take note of all of these things, because in your quizzes on Friday, some of these questions might come up, and I want you to ensure that you do well in it. Okay, alternate angles are sometimes called the Z angle, and the reason is because most times you will find a Z where alternate angles, where they appear. But first and foremost, you need to know that alternate angles are equal. You can write that down as well. Alternate angles are equal. Okay, they are alternate angles in form of letter Z. Okay, so now let's go back to our parallel lines and transversal. We have these two parallel lines, and then we have a transversal like this. Okay, and then we said that there is what we call alternate angles somewhere here in form of letter Z. So let's see if we can trace a Z. If you trace this line like that, and then you trace this line like this, and then you trace the other line like that, you can see that Z formed. Okay, this is where alternate angles appear. So this angle here, the angle inside the Z here, and the angle inside here are called alternate angles, and they are equal. Okay, so it means that angle A and B are equal to each other. Okay, because they form a Z. Please don't forget this. Okay, so angles A and B are called alternate angles, and the reason is because they form a Z. Okay, the angle in here and the angle here are equal, they are the same, and the reason is because these two lines are parallel lines. If you see lines that are not parallel, please, this will not apply. Okay, this will not apply, but since they are parallel lines, then it works. Angles A and B are called alternate angles. And then you could also have angle C over here and angle D over here, and somehow it also forms its own unique kind of Z. If you look at it, okay, something like that. Let me show you something like this. This line, and then this line. That's a Z somewhere here and here. C and D are also angles. They are also alternate angles. So C is also equal to D, and it's basically the same reason. Alternate angles in form of letter Z. Now the second kind of angle that I want you to look at under parallel lines and transversal is what we call the corresponding angles. Corresponding angles basically means it's the same. Okay, it's just like a copy of the former angle, as though you have an angle and then you copied it. If you copy something, it's exactly the same as the copied. Okay, so that's what we call corresponding angle. It's just exactly the same. It's just in another place. Okay, not at the same point as the other one. So sometimes it's called the F angle. Corresponding angles are also called the F angle, and they are equal. Okay, so we will return to our parallel lines and transversal, so that we can see where the F angle is. Now, if you look at this line right here, and you look at this long line, and then you look at this other one, you can see the F formed there. Okay, and for the F angle, the angle in here and the angle in here are equal. Okay, they are called corresponding angles because they are basically the same angles. Okay, just not at the same point. So you have A and B. Okay, the F angle, please don't forget the F angle, A and B, and these two angles are also equal. Okay, they are corresponding angles, so they are equal. All right, but that's not the only corresponding angles you have here. You could also have this angle C here and angle D here. Now, if you I don't know if you're using a mobile phone, if you can turn your phone upside down, you would see that this is also an F. Can you see that? You see that it's also an F, even though it might be facing the other direction, or like an F that is inverted. Do you understand that? Okay, so those two angles are also equal. C and D are the same. All right, and it's because they are also corresponding angles. Okay, we would use all of this in an example, and then I'll give you an exercise that'll give me a feedback of how well you understood it. Okay, so we have talked about the Z angle, we have talked about the F angle. Okay, the Z angle is called alternate angles, which are equal in form of letter Z. They are equal. We also said the F angle, they are corresponding angles, and they are also equal in form of letter F. And if you remember, we also mentioned vertically opposite angles. They also form a letter X. You remember that? Okay, all of those are equal. Now the third kind of angle I want you to look at under parallel lines and transversal is what we call the opposite interior angles, and these opposite interior angles are supplementary. Supplementary means that when you add them together you will get 180 degrees. Okay, that's what supplementary means. All right, and sometimes this is called the C angle because most times it forms the letter C. All right, so let's see if we can prove that. We go back to our parallel lines and transversal, and if you trace this line right here and you trace this other line and then you trace this other line, you can see the C formed. Okay, there's a C. All right, now don't forget we said opposite interior. Interior means the ones inside. Okay, please don't forget that, the ones inside. So it means that the angle inside here and the angle inside here, if you add them together you will get 180 degrees. Okay, so we can call the angle in here A and the angle here B. Okay, and if you add A and B together, because they are opposite angles and they are interior angles, then you add them together, they'll give you 180 degrees. Please don't forget this. Opposite interior angles are supplementary, or they add up to give you 180 degrees. Of course, that's not the only place where you have opposite interior angles. The angle C here and the angle D here are also opposite interior angles, like as though the C is facing the other direction. You understand? Okay, and if you add C and D together, you will also get 180 degrees as well. Okay, so let's see if we can answer a question on this, and then I'll give you exercises which you have to revert to me latest by Friday, don't forget. So this is the example. We have to find the unknown angles in the diagram below. We have to find the unknown angles here, and we have 4 angles that are unknown. We have A, B, C and D. Okay, but they give us 2 angles which we know. We have 123 degrees here, and then we have 55 degrees at the other side. Okay, so maybe we start with A. Can you see a Z right here? Yes, I can see a Z. Now please, it's important to note that this arrow is actually showing you that those 2 lines are parallel. Many times arrows indicate that they are parallel. Okay, because you remember I said that if they are not parallel, you cannot find alternate angles, you cannot find corresponding angles and things like that. They have to be parallel lines. Okay, and the transversal is a line that joins them. So you have this line here is a transversal, and you have this other line here is also a transversal. So there are 2 transversals in this question, and of course 2 lines that are parallel as well. But to answer question A, I can see the letter Z right here. This is the Z I'm tracing here, and so it means the angle inside here is the same value as the angle inside here. So A would be equal to 55 degrees, and the reason is because they are alternate angles. It's important to also let us know what the reason why you're saying that A is 55 degrees, because if you just said A is equal to 55 degrees, then I might assume that you copied it from somebody or that you just guessed. Okay, so it's important for you to tell us the reason why you think it is so. A is equal to 55 degrees because they are alternate angles. Okay, and then let's see what else we can answer here. If okay, beautiful, we can also sort out C. If you look at C right here and this 123 degrees, they both form angle on a straight line. Is that so? Of course it is. You can see this straight line, this line right here. You can see this line right here is a straight line, and the addition of all angles on that line is 180 degrees. That angle has been divided into 2, and you have 123 at one part. Of course you would have C, you have C at the other part. So it means that if you subtract 123 from 180 degrees, then you get the value for C, which will be 57 degrees. And what's the reason for that? Because they are angles on a straight line. Okay, very important to keep that in mind. And if we know the value of C, then obviously we know the value of B as well, because I can see a Z here. Can you see that? Coming from here down to this point, and then comes down here and then to the other side. So these are alternate angles as well. So the value of B and the value of C are equal. So if C is 57 degrees, obviously B is also 57 degrees. Okay, so that leaves us with D. And of course, if you look at this upper line as well, this is a straight line, and the sum of angles on this straight line is 180 degrees. And that angle has been divided into three. You have B, you have D, and 55. So we already know the value of B to be 57, so we can insert that value. 57 plus D plus 55 will give us 180 degrees. So if you add those two together, you get 112 degrees, and you move it to the other side. You subtract 112 from both sides, and then your final answer for D will be 68 degrees. Okay, so that's basically how to answer all of these kind of questions. You watch out for your Z, which will give you the alternate angles that are equal. You watch out for your F, which will give you corresponding angles that are equal. In this case, there are no corresponding angles, so we didn't bother to use that. You watch out for your C, which will give you opposite interior angles, which are supplementary. Opposite interior angles are not equal, they are supplementary. If you add them together, you get 180 degrees. Okay, so you watch out for all that. You also, of course, you watch out for angle on a straight line. You also watch out for angles at a point, and you watch out for the alternate angles. Vertically opposite angles. Vertically opposite angles. Okay, which will be formed when there is a giant X. Okay, so basically that's how to answer these questions. This would be your second assignment. You remember the first one I gave you earlier on, so you can rewind the video back to that point so that you can copy them out. And then the second assignment is right here. There are 4 questions. I expect these by Friday as well. Okay, all exercises should be done and sent in on or before Friday, and this will be for all the students in grade 7. Okay, so whether you're from the high school or from the college, send the answers to my email. And please don't forget, you are to draw the diagrams in your notes and answer the questions and make them neat. I would appreciate if you can have 1 question per page, okay, so that it's neat, and you scan it and send to my email. Just send it together, so that I would get back to you on them and see how well you perform. So spend your time to look at this, and I'm sure that you're going to be able to figure it out. Also, do not forget you have your quizzes on, I think it's Thursday. Okay, so I'll be testing you on this discussion that we have had on identifying angles and talking about their properties, and of course answering questions on those angles. All right, so basically that will be it for this class. Thank you so much for your time. I would expect your assignments in earnest. Bye bye.